Good morning, my integrated math learners. Today we are going to work on functions. I'm going to show you a pretty easy method to check the relation and see if it is a function. So we are going to do something called mapping. Now what I would do if I were you is I would have out some paper so that you can follow along with me, because it's really important that you write this down too, because as you write, it sticks in your brain. Okay, so yesterday we talked about coordinate pairs. Remember, coordinate pairs have an X and a Y. Now remember, your X is your input, your Y is your output. So we're going to make what we call a mapping diagram. So I am going to actually go ahead and just make a big circle here. And I'm going to make a big circle here. You're going to see this in math. Now remember, this is an input. This is an output. So now what I'm going to do my mapping diagram is I'm going to take all my X's and I'm going to put them in my input circle here. So notice I have a 1, I have a 2, and I have a 3. Now what I'm going to do is take all of my outputs. I have a 4, I have a 6, and I have a 9. Now, the reason we call this a mapping diagram is we're going to connect the input with the correct output. So notice that 1 becomes 4. So I'm just going to draw my arrow. I notice that 2 becomes 6. And I notice that 3 becomes 9. Since we have a 1-to-1 relationship, 1-to-1, 1-to-1, this is considered a function. So let's go ahead and check our next set. So again, I'm going to put my input on one side, and I'm going to put my output on the other side. Now remember, this is my input. I'm going to use I for input. This is my output. Yesterday, we also called this our domain, and this is our range. And if it helps you, these are the X's, these are the Y's. Remember, we have multiple names for this first value. So now I'm going to find all my inputs. I've got 2, I've got a 3, I've got a 2, and I've got a 5. On this side, now I did put 2 twice. You can just keep the 2 one time. In fact, maybe we'll do that a little bit later just so I show you you can do that. Now our outputs are 6, 4, 7, and 8. So notice that my 2 becomes a 6. Okay, my 3 becomes a 4. My 2 becomes a 7. So technically, this 2 also becomes a 7. Do you see how that happens? It's easier if you just write the number once so you can see it. Okay. And there's often times when I'm doing this that I actually have to cross one of them out just so that I can see what's happening. Then I have a 5 becomes an 8. Now, if you'll notice, I do have 1-to-1 here. I have 1-to-1 here, but I have a 1-to-many. I have 1, which is the number 2, is becoming a 6, and it's becoming a 7. This cannot happen in a function. So this is not a function. And I ran out of space. Not a function. It is not a function because my 2 became 2 different answers. Not a function. Okay, let's look at our next one. Here I've got 4 values again, or 4 XYs. Okay, so I'm going to go ahead and make my XYs. And so first I have a 1, my 2, my 4, and a 5. Now I'm going to go ahead and put in my Y values. Remember, X and Y. My 3. Ooh, another 3, so I'm just going to leave that 3. And a 7. Notice that it's another 7. So you only have to write it one time. So now let's go ahead and draw our arrows. 1 became 3. 2 became 3. 4 became 7. And 5 became 7. Now, we haven't really talked about this one. Notice that my 1 only becomes a 3. My 2 only becomes a 3. My 1 doesn't become anything else. My 2 doesn't become anything else. My 4 became a 7, and my 5 became a 7, but my 4 only became a 7. It didn't become anything else. So what this means is it is a function. Now we can call this a many to 1. It is still a function because 4 only becomes 7. 5 only becomes 7. Now 4 and 5 both become 7, but that's okay. I'll show you a picture in a few minutes to help you understand this. Okay, let's do one more and see if it's a function or not. And I want you to think about it before I give you the answer. Okay, let's go ahead and draw our XY. At any time, if you want to try to do these on your own, pause my video and then you try it and then you come back here and check my answers. Okay, notice I have all my X's. I have a 3, I have a 6, I have a 7, and I have an 8. Now my Y's, 2, 10, 6. Oh, I have another 2. Okay, that's telling me something. Okay, now I'm going to draw my arrows. 3 becomes 2. 6 becomes 10. 7 becomes 6. And 8 becomes 2. Do I have any many to 1s or 1 to 1s or 1 to many? So 3 became 2 and 8 became 2, but 3 still only went to a 2. It didn't go to any other number. And 8 only went to 2. It didn't go to any other number. So that is okay. That is still a function. My 6 became a 10 and my 7 became a 6. So this one is, what do you think? A function. Now, just to help you understand, I did draw a diagram. So if you want to, you can take notes on this. Now remember, when we're looking if a relation is a function, if it's a 1 to many, so like if a 6 becomes a 4 and a 3 and a 2, it is not a function because I have one X becoming many Y's. That can't happen. If it's a 1-to-1 correspondence, then it is a function. So say 6 becomes 8 and 7 becomes 10. That's a function. And the many to 1, that is also a function. So say I have the number 8 becomes a 2, and then 4 becomes a 2, and 7 becomes a 2. That is still a function because the 8 only goes to one number, the 4 only goes to one number, and the 7 only goes to one number. Okay, make sure you've taken good notes. If you need to, pause and go back and watch it again. That always helps. I'll see you in class.